Hello, everyone. On behalf of BIC Alliance and Draeger, I'd like to welcome everyone to today's webinar, How to Test and Select Breathing Equipment to Maximize Your Worker Protection. This is Robin Dupree from BIC Magazine. Before I introduce our presenters, a few housekeeping items. You can resize or hide any of the windows in the webinar console. For example, you can maximize the slide presentation window. At the bottom, you will see widgets to access resources, including a Q&A link to submit questions during the presentation. If your question topic does not get addressed, someone will respond to you individually in the coming week. Again, you can ask questions at any time during the presentation, and we encourage for each of you to do so. If you experience any audio or other technical problems, click on the yellow question mark icon, and we will address them accordingly. You will need speakers in order to hear this presentation. And now, it's my pleasure to introduce our sponsor and presenter. Draeger is an international leader in the fields of medical and safety technology. Founded in 1889, Draeger is currently present in more than 190 countries and has more than 13,000 employees worldwide. Aaron Chapman started with Draeger in July 2001 as a mechanical engineer and moved into his current role as product manager for industrial products in May 2008. Prior to Draeger, he worked at Bell Valves as a project engineer. Rosie Madison graduated from Newcastle University with a master's in international marketing prior to joining Draeger's UK marketing department in 2011. She is also now a product manager and works closely with the products team. Now I'd like to hand the mic over to Aaron for today's presentation.
Great. Thank you for that, Robin, and welcome from me as well. I can see a number of people online already, so it just shows what an important topic this is. With me is my colleague, as mentioned, Rosie Madison.
Hi, and welcome from me also. Throughout this presentation, I'll give you help with Aaron with any questions that come up, and this will end in a minute.
Great, thank you. Right. During this session, I will be explaining the best practices for respiratory protection equipment, which sometimes referred to as RPE, and I will use that abbreviation throughout. In terms of breathing protection offered based on the standard practices and enhanced product performance testing, highlighting facial factors as well as the pros and cons of different test methods. I'll have a small presentation running in the background for your reference. This can be shared upon request by contacting Rosie, Robin, or myself. I will be including different protection factor values based on various respiratory protection equipment with a focus on self-contained breathing apparatus. What we won't address is RPE selection specifically, any specific applications, or risk assessments. As mentioned already, please feel free to post any questions at any time, and Rosie will be monitoring this. We'll raise the questions straight away if possible, or we'll hold them to the end, and there should be time at the end for us to review the questions and give the answers. A quick look at the agenda for today. I will start by explaining what is meant by protection factors, the basics if you like, showing how these are established and validated, and give an overview of the different levels assigned by different types of breathing protection equipment. Next, I will look at face fit testing based on explaining what it is, how it is applied and conducted, as well as explaining why is fit face testing important. I will then identify what are the influences from different faces, looking specifically at the size and shape, marks, abrasions, scars, and facial hair. Finally, I will be going through what is enhanced protection factor testing techniques, what are out there to establish high protection factors, and how these enhanced protection factors are validated. There will also be time at the end, as mentioned, for a quick summary and further questions. Any feedback would be greatly appreciated as well. Please feel free to post your questions at any time now. So what are protection factors? Protection factor is the level of protection that a wearer may expect to achieve from a given respiratory device. Or in other words, the difference between wearing a device and not wearing a device. Factor is calculated by dividing the concentration of a substance outside the device or the face mask by the concentration of the substance inside the device or the face mask. So really, it's just a simple fact. There are different values given to these protection factors in different terms. So a nominal protection factor is something that is a general and theoretical protection based on laboratory measured performance and is the amount of the breathing protection that can be achieved realistically by 95% of the well-trained and supervised personnel. An assigned protection factor is something that's associated by various countries and is, if it is available, overrules an NPF, a nominal protection factor. So the APF may be different and would take precedence in certain regions where they are applied. You need to check with your local regulations for the relevant protection values.
Okay, Aaron. So what about workplace protection factors? I haven't mentioned these ones yet.
Yeah, thanks, Rosie. That's a good question. The workplace protection factor is a protection assessment carried out on a specific device with a specific worker. So a personal protection factor, if you like. These are real-world figures that a worker can expect to achieve. And I will go into more detail on this later on.
Yes, thanks, Aaron.
As shown, the protection factors on screen you will see, these are typical values for different types of device in accordance with European norms. There are figures for OSHA and US norms as well. These factors can be assumed for respirators from different manufacturers of the equipment and meet relevant approval standards. So that means if any device is approved to EN 137 from any supplier or any manufacturer, it has a nominal protection factor of 2001 as shown in that chart. How are these numbers applied though? To establish the respirator device type suitable for use in a certain environment, it is important to first know the allowable exposure rate for the given hazard and the environmental level for that hazard. Please be aware that similar to the protection factors, this allowable rate can be different for each region or country or health organization. As shown, the concentration of a hazard should be divided by the exposure limit allowed. So in the example on the screen, we have 1,000 parts per million concentration in the environment with an allowable exposure limit of 10 parts per million. This means that the device to be chosen must have a minimum protection factor value of 100 to 1. If we go back to the chart that we showed earlier on, the table shows various devices with the protection factor. So anything with a factor higher than 100, which you can see is highlighted with the red bubble there, is a suitable device to be used in that application. Another way of looking at it is that if you know the maximum concentration allowed for a device, then you can work out the exposure limit allowed by that device. So the calculation for this is to multiply the exposure rate by the protection factor. So the example shown is for H2S, sour gas, hydrogen sulfide, whatever you want to call it. So the exposure limit for this is 10 parts per million. With a protection factor of an RPE, in this example of 1,000 to 1. So the environmental limit would be 10,000 parts per million.
Okay, so it's just a simple calculation then?
Yes, it's as simple as that. Sign protection factor and normal protection factor is multiplied by the allowable exposure rate. However, it should be noted that there are other influences on this selection. For example, the oxygen level must be at a certain point for you to use filtering devices, so there must be more than 18% oxygen in the environment to use a filtering device. If that is lower, then you would not be able to use a filtering device. The materials of construction also may have an influence. So certain materials may not be compatible with certain environmental conditions. So this may have an influence on the type of device that you would want to use as well. Well, how do we know that the respiratory protection device is suitable for the user? Certain countries, the UK, the US, and Canada, for example, it is mandatory for the wearer of a PPE to be tested that that device is suitable for him or her to use. We call this face fit testing.
Okay, so who's responsible for the actual face fit test? Is it a legal requirement for the employers to offer the service for the face mask?
Yes, absolutely, and that's a good point, Rosie. It is a legal requirement in most countries for anyone who wears a tight or close-fitting mask for work to be tested. This should be organised by the record and records maintained by the employer. Also, the test must be performed on each type of face piece that the user may use. This means that if there are more than one device available, each and every one should be face fit tested on a regular basis. We must remember a poor fitting face piece may not provide the protection factors referred to earlier in the tables.
So if this is correct for all breathing apparatus, like including hoods as well?
No, it is only a legal requirement for anyone who wears a tight-fitting mask. In other words, face pieces that seal against the wearer's face. For face fit testing, there are two basic types of testing. A quantitative test. So this test measures accurately the fit and the amount of leakage into the respirator. A qualitative test, however, has a pass-fail criteria that relies on the test subject's response to a test agent by either smell or test. Procedure is performed by the test subject being shown how to correctly wear the device, followed by an assessment that the device is fitted correctly, and then exercises are performed at normal and heavy breathing rates, trying to detect the hazard by either smell or taste for the qualitative tests, or measurement of the leakage inside the mask for quantitative tests.
Was that it for life then, Aaron? Do you need to get retested again, or is that the end?
No, that's not it, actually. In some regions, a retest frequency is also a requirement. So, for instance, in Europe and in the US, the test must be repeated every year, whereas in Canada, the retest must be performed every 2 years. Also, if any phase changes have taken place, so for example, if you gain weight or lose weight, if you have any major dental work or facial injury leading to a scar, these will all necessitate retesting. This is the only way to ensure continued protection from the respirator. Also, the guidelines for testing require that the wearer is clean-shaven, as facial hair could have an influence on the ability of the device to seal. This is an issue where beards are worn, and I will discuss this later on in the presentation.
Right. So what happens if you actually fail the test?
And this does happen. If the test person fails the test, then this device is not suitable, and another device type needs to be selected and face fit retest carried out. This device may need to be from a different manufacturer or supplier, as different face masks have different fit characteristics. Not all face pieces are suitable for all people, it must be remembered. So facial influences. As mentioned earlier, the size and shape of a face and facial features have a huge influence on the protection offered by a respiratory device. Some faces are long and narrow, some short and round. Nose sizes and lengths, or Charlton Heston's chin, for instance, may all have an influence on the sealing of the face mask. The new ISO standard that's been recently introduced tries to take these facial differences into account. As you will see on the screen, different face sizes have been categorized in the shape as shown in the chart. So you have short, long, narrow, long, short and wide, plus others. So the numbers inside the oval, they represent 95% of the personnel. There's a requirement of the supplier of the equipment to apply for the approval for the categories suitable for each device, which means that the supplier of a face mask must identify which categories, as shown on the chart, they want that device tested against. And it is the approval authority's responsibility to test the respiratory device and its suitability for those categories. So in those cases, the test subjects will be chosen based on the size and shape of their face. The testing will achieve the nominal protection factor levels quoted earlier on in the presentation. There's no difference to the protection offered. All it's doing is taking into account various face shapes. Another concentration is facial hair, pimples, marks, scars, etc. The wearer must be clean shaven where the mask seal meets the face. This is because facial hair could prevent the mask from sealing correctly against the face. Anything, in fact, that is on the sealing line of the respirator mask has the potential to adversely affect the sealing performance. Currently, there are no recognized test protocols to support facial hair, so protection factors are not available for this face type. The problem you have is that facial hair will change day by day, so you don't know what influence it has had on the sealing performance of the face mask. Now, this is an issue where beards are worn for fashion or religious reasons. As I say, a beard will grow each day, and this could be assumed to change and therefore could affect the protection offered by the device. Test protection for bearded use, appropriate guidelines needs to be developed for us to test against. We don't have that at this point in time.
Okay, so it seems that the highest protection factor available is 2000 to 1. What if the user requires a higher protection factor?
That's a good question. It's not easy to confirm, and it is the next topic on the agenda, enhanced protection factors. Other testing methods are available which give true protection factor for that person. For example, one method is termed the working protection factor that you reminded me about earlier, Rosie. This requires that the worker to be quantitative tested, carrying out his or her working duties, wearing the respirator device whilst being subjected to the actual hazard.
That surely can't be safe.
Maybe yes, maybe no, that depends on the hazard. But you are correct, probably not safe. So, for example, I have had requests from some customers requiring protection against H2S in the hundreds of thousands of parts per million. In fact, one at 450,000 parts per million. So in this case, it required a protection factor from the device of 45,000 to 1. As you can appreciate, this is significantly higher than available from the standard testing described earlier. Testing the protection at this level of hazard would not be wise. If the device leaked, that could lead to injury or death to the person.
So, Aaron, what can the companies do to protect the user as well as continue on with their production?
I can't comment on other PPE suppliers, but what I can do is tell you what Draeger have done to support this. We worked closely with a certifying authority in Germany to design a test protocol. We developed a program we call a simulated working protection factor. What we use is the ISO face sizes from the new ISO regulations, as I showed in the previous slides. We use a higher cohort of test subjects. So the EM test protocol only requires 6 people. We use in excess of 12 or 15 test people to get a more average test result. We use the test protocols from EN approval standards for positive pressure self-contained breathing apparatus, and we use a test gas called SF6.
Why is this particular test medium used?
Well, testing can be conducted with various test mediums. So it could be gases, it could be aerosols, it could be liquids or dusts, and each will have a different result. Draeger chose SF6 test medium as it is a gas. It is safe for the test person and more closely resembles the performance of various gaseous hazards that we have come in contact with in our applications. This means the sealant performance against the medium. If you consider dust particles is much larger than an aerosol particle, which in turn is much larger than a gas particle. By using SF6, this means the sealant performance will be closer mirrored to a gas and therefore give a more realistic value. So, for example, using an aerosol in the test medium cannot give a good assessment of protection offered against a gaseous hazard. This is why we have the working protection factor. The test medium would be the actual phase of the hazard that the wearer would come into contact with. So the test results we obtained give an expectation of what a protection can be expected on Draeger positive pressure face mask devices based on gases. And what we achieved in the final results is a safe working protection factor 90,000 to 1 for 90% of the population. So by using the ISO chart, we get most of the population. We chose test subjects with the various faces as shown in the ISO chart. And we achieved 90,000 to 1 protection for those people. And for the face sizes that fall outside that chart, we have a protection value of at least 20,000 to 1. How does this compare to the customer request? This means that with an allowable exposure limit for working of 5 parts per million for H2S, we have an exposure limit of 5 times 90,000 to 1, which gives us allowable exposure limit of 450,000 parts per million. That's right in line with what our applications have been required. So in summary, different protection factor values are available in different countries and different regions. The nominal protection factor is offered by standard approval testing methods. The design protection factor is a national factor available in some countries and will take precedence over a nominal protection factor if it is available. The working protection factor is an accurate value based on real-life conditions and hazards that the worker would come in contact with, and simulated working protection values are a safe assessment of what might be expected or what the user will expect from a given device to use in a given application. With the Draeger assessment offering a protection factor of 90,000 to 1 for 90% of the personnel. Regular face testing is required to ensure continued suitability for a device, providing evidence that the NPR and the APR can be achieved. Any changes in weight or facial features should trigger retesting, and retesting may be required on a regular basis depending on the regulations of the local country. Wearers should be clean-shaven in accordance with the regulations. Let's see if there's been any questions. Rosie?
I haven't had anything come through on the line at the moment.
There was one question that came to me earlier on, which is the difference between a positive pressure face mask and a nominal pressure face mask. what I can say is that a positive pressure face mask gives the highest protection factor because it maintains pressure within the protective device at all times, meaning that a hazard cannot penetrate that pressure. A nominal or negative pressure device is a constant flow device which constantly leaks air outside of the face mask. It has an advantage that it regularly replenishes the air, so it cools the wearer down, but because it is always overcoming the seal on the face, it does not offer as high a protection as a positive pressure device would offer. And that is it from us. There is no questions on the line. Oh, so we had some questions from some colleagues who want to dial in, and it's not working very good. Hopefully that technical issue was solved. And that is the end of the presentation for today.
Okay, thanks, Aaron, Rosie. I appreciate it. And we thank Draeger for sponsoring this educational content, and would like to remind each of you that you can visit them at draeger.com. The recorded version of this presentation will be available in about 2 hours at bicwebinars.com. Feel free to watch it again and share with your colleagues. On behalf of all of our friends at BIC Magazine, thank you.
Thank you, everyone.
Thank you.